All right, so we're back today with our properties of exponents and radicals. These are the same properties that we've been using for exponents for quite some time that you learned before, but now I just want to give us some specific examples where we're dealing with exponents that are fractions which transpose to radicals. And then yesterday we talked a little bit about how you could add and subtract, but these properties today are more along the lines of mostly multiplication, division, power to a power. And so I'm going to go pretty quickly through these. When you have the same base and you multiply those bases to an exponent, you end up adding the exponents. And so this allows us now to have 3 to the 1/2 plus 3/2. Just be aware today that if these are not the same denominator, you're going to have to change them to a common denominator. These ones are. This would be 3 to the 4/2, which is 3 squared. Division of powers of the same base. When we have division, we subtract those exponents. And so if I had 4 to the 5/2 divided by 4 to the 1/2, I can write that as 4 to the 5/2 minus 1/2. Again, these have a common denominator already, so I could rewrite this as 4 to the 4/2, and I can reduce that fraction to 4 squared. So I'm really working on writing these as a single base. And I have some questions on that in a little bit. Power to a power. When we have power to a power, we multiply the exponents together. And so when those are fraction exponents, we have some things. So this is 3/2 times 2. Those 2's cancel. This is x to the third. 4 to the 5/3 times 3. Again, 5/3 times 3. Those 3's cancel. This is 4 to the 5th. And importantly, what we need to understand is if you have a radical raised to the exponent, I would change them both to exponents. We'll do an example in a minute. And then I would do that from there. So these rules apply if you're doing radicals or exponents, because a radical is just a rational exponent. That's kind of the main takeaway of this. Okay. So if I had AB to the m, a parentheses raised to the m, that means each thing, I don't really call it distribution. It's not really, but that's what the property, I guess, if you want to think of it that way. You have to apply the power to both things in the parentheses. This would be 4 to the 1/2, x to the 1/2. Okay, 4 to the 1/2, x to the 1/2, 4 to the 1/2. If we get our root card out, this is one we know. That's the square root of 4. That's 2. We could write this as 2x to the 1/2. Also depends on what they're asking for. If they ask me to leave it in as an exponent, I could leave it that way. If they ask me to write it as a root, I can write it as a square root. So division. Okay, so by the way, these two, go together. The point is if this is really an exponent, a root is really an exponent, that root applies to both of those things, okay? Same with division. These two go hand in hand. In fact, let's hop down here. So if I had these two, I could put them together. You could simplify them individually. Like I actually know the cubed root of it, but I could also put them together as the cubed root of 8 times 3, which is the cubed root of 24. Now, in this case, if depending what the goal is, if I wanted to simplify, I'd have to go back and take out the cubed root of 8 anyways. Okay, depends on what the goal is. Okay, so on division, we'll do these two together. Whether it's an exponent or a radical, you can separate those things. Vice versa is also true. If you see them written this way, you can put them back in that form. Again, it depends on if you see that it can simplify one or the other way. If you know those things, like in this case, I know 8 to the 1/3. That's the cubed root of 8. Okay, cubed root of 8. Cubed root of 8 is 2. And the cubed root of 27 is 3. And so this would be 2 over 3. Negative exponents mean to take the reciprocal. When we're looking at that in fraction form, still the same thing. This would be 1 over 25 to the 1/2. 25 to the 1/2 is the square root of 25, and the square root of 25 is 5. So we could actually go further to 1/5. If I'm going to actually add something here, if we have a over b to the negative m, when it's in fraction form, we take the reciprocal by reversing or flipping the numerator and denominator. And then it would be applied to both the numerator and denominator. So in this particular example then, we have 8 over 3 to the negative 1/3. So this is 8 to the negative 1/3. I'm going to flip it, sorry. 3 over 8 to the 1/3. This would be 3 to the 1/3, which I do not know, and 8 to the 1/3. I do know 8 to the 1/3. I can leave that as 2. 3 to the 1/3 I can't do anything with. We don't know the cubed root of 3. Let's go to the division here. So here I actually did it differently. So I might want to take something that's written individually and put it back together. So as long as the roots match, I can make this 16 over 2, because then it might give me something I can simplify. 16 over 2 is 8, and I know the cubed root of 8, and the cubed root of 8 is 2. So a word of caution, simplified expressions will never contain a 0. Oh, I should talk about that. And they will never contain a negative exponent. A reminder about that. Anything to the 0, in case I need to remind you, the reason why there'll never be a 0 exponent, anything to the 0 exponent is 1. It represents the identity in multiplication. An identity is what would you multiply by that would not change what you're multiplying by. Sorry, that didn't come out right. So in other words, if I had 5, what would you multiply 5 by that would still give you a 5? It's 1. Exponents are repeated multiplication, so therefore I would need the identity to be 1. All right, so when we're doing some multiplying and dividing of radicals, we're going to multiply the outsides together, multiply the insides together. Any rules that we just discussed, you can apply, meaning that if you have a power to a power, you can multiply them and such. So in this case, I have 2 radical expressions. With outside, I have a 2x. I'm going to put 2x times 5 together and leave that on the outside of the radical. And underneath the radical, I have a 3x times 6x. So that's our first step. We multiply the outsides, leave it outside, multiply the insides, put it inside. 3 times 6 is 18, and x times x is x squared. The next step is if you can pull out perfect squares and simplify, now do that. Nothing changes on the outside. I could rewrite 18 as 9 times 2, and x squared is already an even power. So I can take out the 9, and I can take out the x squared. The square root of 9 is 3. So now that's going to be 3 times 10. And the square root of x squared is x. I can multiply multiply that x by this x here. So this gives me on the outside 30x squared. Since these two came out of the square root, the only thing underneath the square root is the square root of 2. Let's try that with another one. So on this particular one, the only thing outside the radical is a squared. So I'm going to leave that out. When I multiply two radicals together, that's one of the properties we talked about a few minutes ago, you can multiply those things and put them together under the square root. I'm going to do that. I'm going to write an in-between step. I'm going to leave a and a squared written this way because I'm going to be able to take out the a squared. It's an even power, and so that's an advantage. So I'm going to leave it as a squared times a. B to the third is not an even power, but if I multiply by b to the first, it is. So, all right, so I take out my perfect squares, which is my a squared and my b to the fourth. The square root of a squared is a, so that's going to come out here. And the square root of b to the fourth is b squared. So underneath my radical then, since those are gone, I have the square root of a. And I have a times a squared is a cubed. And then I have b squared. All right, let's take a look at a power to a power situation. So this is kind of interesting because I have exponents here, but then I have this radical here. So first thing I notice is I have two things raised to the second. So I'm going to separate that and apply that second power to both the square root of a cubed, and then also to b to the negative second. The rule is with exponents, you multiply your exponents together. I don't know if you're aware, but a square root and a squared cancel. And if you're unaware, I'll rewrite it. That square root symbol really is the 1/2 exponent. And then I'm squaring it. I don't know why I wrote another negative 2 there. Should be positive 2. All right. Negative 2 times 2 is negative 4. What happens when I multiply 3 times 1/2 times 2 is 1/2 times 2 cancels, and that leaves me with a to the third. We already addressed this is b to the negative fourth. One of the things we mentioned is it's not proper to have negative exponents. This b to the negative fourth is the same as 1 over b to the fourth, and so I can put it together as a to the third over b to the fourth. All right, let's do a few of our properties with numbers to rewrite as same bases. So this example is saying use the properties to simplify and find a and b. So I'm trying to basically put these together as one number to an exponent. We talked about if the bases are the same, we can add our exponents together. Unfortunately, our exponents do not have the same denominator, so what I'm going to do is change the denominator of the 1/2 by multiplying by 2 over 2. And then I have 2/4 plus 1/4, which is 5 to the 3/4. I now have it written in the form that I ask for, and so I ask for a and b. A is the base, a equals 5. B is the exponent, b equals 3/4. Okay, let's try one with subtraction. So subtraction, I have 7 and then divided by 7 to the 1/3. So that really means 7 to the first. And the rule for division of the same bases is we subtract our exponents. Once again, this is a 1, take away 1/3. So in your head, you might know that. Hey, that's 2/3. If you don't, you can multiply or change this to 3 over 3. 3 over 3 minus 1 over 3 is 7 to the 2 over 3. I now wrote it as a single number raised to a power, so A would be 7. B would be 2/3. Okay. Let's try one more. Well, maybe two more. So this one I'm already telling you what the base is. I'm going to write, I want you to write this as a base of 4. So let's see if we can simplify this. I notice there is a power and they're raised to a power. So you kind of have two ways you can do this. You can put these together and raise to the 1/2, or you can raise them both to the second power together. It kind of just depends on how you want to look at it. I'm going to raise each individual multiplier to the second power and use the power rule. So 8 to the 1/2, the 1/2 times 2 cancels, and that just gives me 8. 2 to the 1/2, those exponents multiplied cancel. That gives me 2, and 8 times 2 equals 16. But I want you to write it as 4 to some power. So hopefully you know that 4 to the second power is 16, and I ask you to find B, so B equals 2. Okay, let's try one more of those. On this one, I'm going to actually divide them first. The rule that allows me to divide these first and put them together is the rule that we talked about right here. So either with a root or with exponents, you can use them back and forth to get what you need out of it. So the reason why I'm choosing that here is because I notice when I square a 1/3 that's not going to get rid of that exponent for me. And so I'm going to be stuck with this 2/3 exponent. So what I'm going to try to do first is, can I try doing 12 divided by 4 first and raising that to the 1/3, and that's then squaring it. Sure enough, I noticed 12 over 4 is 3, which is kind of what I wanted. So I had 3 to the 1/3 squared, and I wanted to write it as a power of 3, so that works out. I multiply my exponents together. This would be 3 to the 2/3 power. I asked you to write as 3 to some power. B equals 2/3.